Okay, welcome to the new lecture. In this lecture, we will learn how to sort pandas data frame. So, sorting is an important step in data analysis to recognize and structure the information for easier interpretation and decision making. So, first of all, how to sort the values. So, sort the data frame by the values of one or more columns. So, for this particular purpose, we can make the use of the sort method of the data frame class. So this basically uh, accept four parameters. The very first one is we have to specify a single column, or we can also specify the list of column names, and access is equal to 0 means that we want to sort rows instead of the sorting the column, and ascending is equal to true. It is the default value. It means that we want to sort in ascending order. And the third one is in place. So if in place is equal to true, it will modify the original data frame. Otherwise, if it is false, then it will not modify the original data frame. Okay, so how to sort the index. The second one, it will be the sorting the index. So sort the data frame by its index label, row or column index. For that purpose, we will be using the sort underscore index method. So access will be is equal to 0, ascending is equal to true. Will sort the indexes based on the ascending order, and in place is equal to false, mean that it will not modify the original data frame. So x is equal to 0 sort by row index default, and 1 is equal to sort by column index. If ascending is equal to true, it will sort in the ascending order. Otherwise, descending order. In place is equal to true, then it changes the original data frame. Otherwise, it will not. And we also have the kind parameter, and if the kind parameter is set to the quick sort, then the sorting will be done by using the quick sort algorithm. Okay, now sorting a data frame by a single column. So sorting by a single column in ascending order. So now consider the sample data, that is, it contains the name, age, and score as the key in the dictionaries, and these are the corresponding values against each key in the dictionary. Now we'll be importing that dictionary into the data frame. As a result, df will contain the resultant data frame. So first we will be displaying the resultant data frame. Okay, so first let me clear all the outputs, and here all outputs of all cells. So I will execute it first. So now, as you can see, that this is the original data frame which we have imported from the dictionary. So it does not have any row indexes set, so the default row indexes are from 0 up to n-1, and then we have the name column, the age column, and the score column. Okay, so now we want to sort this particular data frame based on the name column. So what we will do is that we will use the data frame object name, and then the dot operator, and then we will be calling the sort values method, and within the method we will specify only a single parameter, that is by is equal to name, which means that this particular data frame will be sorted based on the name columns. Moreover, as we know that we have not specified any more parameters, so the default parameter or will be the ascending is equal to true, access is equal to 0, and in place is equal to false, which means that the default the original data frame will not be modified. So first we have displayed the original data frame before calling the sort values method, and then after the sort values method has been called, it will return a new data frame which we are storing in the sorted underscore df data frame. After that, we are displaying the original data frame so that we could know that it remained unchanged, and finally we will be displaying the sorted data frame based on the name column. So this is the original data frame before calling the sort underscore values method. So this is the original, and this is the original data frame after the sort underscore values method being called. So the original data frame still remain unchanged. We can see that Alice is on the top, Charlie is on the second, Bob and David are on this third and fourth position respectively. So this is the sorted data frame which we have displayed as well. So as you can see that under the age under the name column, Alice has been on the top as usual because it starts from the letter capital A, and then Bob has been shifted to the second place, and then Charlie has been shifted on the third place, and David is in starting from the letter capital D, so it is also on the fourth place, that is unchanged. Now sorting the data frame based on the single column in descending order. So first we have to do is that, okay, there's one thing more, that after sorting the data, we can also see that their indexes are not changed accordingly, because index number 2 was assigned to the Bob in the original data frame. So the index of the row index of the Bob is still 2, which is unchanged. So in case if we want to change it after the sorting, what we can do is that we can make ignore underscore index is equal to true, which means that it will not keep the record of the original indexes, but instead it will reset the indexes from 0 up to n minus 1. So such sort of problem will be solved in the resultant data frame. So we have made one more change here, is that we have set ascending is equal to false, which means that resultant data will be in the form of the ascending order, will sort in the form of the ascending order rather than sorry, it will be sort in the descending order rather than the ascending. So now again, and this is the original data frame in which Alice is on the first position, then Charlie, Bob, and David. So after sorting, uh, what we can see here is that, okay, so display sorted data by age. Okay, sorry, we have to make a correction. We have set this name. Okay, first we can do is that by name, so that we get the output based on the name. So now you can see that David is, since it David starts with the capital letter D, so this is on the top, and then there is a Charlie, and then Bob, and then Alice. So this is what we have done here, is that we have uh, sort the new data frame based on the name column in the descending order. So what if we want to sort based on the age column, and also I want it in the descending order? So let's see the output. So now you can see in the descending order based on the age column is that the maximum values in the top, and then the second maximum, and then the uh, second last small value, and then the smallest value is in the bottom as well. Moreover, you can also see that the indexes have been reset accordingly. So the row that is on the top has now been assigned an index, a row index value 0, and then 1 up to n minus 1. Okay, so parameter of sort values. So we already use sort values couple of time. Now we already know what the by does. It actually selects the column, or we can also select the list of columns here, and then the ascending in place. We also know that now NA position. So there is also a parameter with the NA position, so it controls where n values are placed. Use first to put n not allocated values or the top or last by default. So since we know that not allocated values does not take part in the ascending or descending order, so we can decide what happens with the not allocated values. So if we set na is equal to okay, do we have any not allocated values? Okay, here we have. Okay, so we will come to it in a while. So before that, we will see that how to sort a data frame based on the multiple columns. So again, we have the same original data frame data, and then we have incorporated that data into the data frame. And now I want to sort the data frame based on the two columns, that is the age and then score. So what happens is that the resultant data frame will be sorted in the ascending order based on the age. So if we have a kind of data where we have similar age, as an example, we can see that there is a 25 age here and age here. So let's see the output first. So this is the original data frame. So here we can see that we have age 25 and we also have the age 25. So once as we already know that both of them have the same age, so what should happen, who should go at the top place and who should come at the second place? So this will be decided on the score as well. So first the sorting will be done on the age, and then we can also check the score, that if two rows have the same values of age, that is 25, then whose score is who has the smallest score. So Charlie has a less score than the Alice, so Charlie should go at the top because both have the smallest age, and then among the both Charlie has the smallest. So the resultant data frame contains Charlie at the top because Charlie has the lowest age and Charlie also has the lowest score. On the second one is the Alice, has the same as the Charlie but has greater score than the Charlie as well. So and then Bob and then David as well. So how to deal with the missing values? So since we already know that we have a parameter with the name and a underscore position, so if we set its value as first, it means that not allocated values will be at the top again. So now setting the age column for sorting. So first we will see the original data frame, since I guess we already know, but anyhow I first would like to display the original data frame. So df underscore with not allocated values. So now we can see that we only have two columns. So this is the original data frame. So this original data frame contains not allocated value as well. So now I want to sort the original data frame based on the age column, where I have said that if there are any unallocated or not allocated values, then I want to put them initially, because the sorting is in the ascending order. So it's regardless of the fact that the sorting is in the ascending or descending order, not allocated values will always be on the top. So now we can see that Charlie's age is not specified, so it's on the top, and then Bob has the smallest age, and then David, because both of them have the same age, so that's why the interpreter needs to decide. Interpreter has a choice actually who will come first and who will come at the last, since Bob is already coming before the David, so that is why we can see the Bob here first, and also its index is 1 and then David's index is 3. So anyhow we can see that their indexes are not reset, so we can add here is that reset underscore index is equal to true. So what this will do is that they will okay, so I think ignore underscore index is equal to 2. It's not reset, so it's basically ignore underscore index. So what this will do is that it will ignore the original indexes, and then it will okay, ignore indexes. We have to set it as false to ignore the original indexes and then reset them once the sorting has been done. Okay. Ignore underscore indexes equal to false. It should work. Okay, let me do it. If I set it to true, only then it will ignore, otherwise not. So here we can see that after sorting, the not allocated value is on the top because we have set the not allocated position should be on the first, and then the indexes are also reset, has been resetted, that is starting from 0 and goes up to n-1. Okay, then there is another part of sorting, that is the to sort the data frames by using the indexes. Okay, so here this basically has the axis is equal to 0, ascending is equal to true, and in place is equal to false. Again, we already know that if we set ascending is equal to false, then the resultant data will be sorted based on the descending order, and then if we set in place is equal to true, then original data frame will also be modified as well. Anyhow, so this is again the same dummy data in which we have name, age, and score as keys in the dictionary, and then they also have the corresponding values. So we have incorporated this original data into the data frames. So after incorporating, we can see that this is the original data. Okay, so now what we are doing is that we are sorting them based on the axis is equal to 0 and ascending is equal to true. So what this means is that so what it means is that it will sort the resultant data frame based on the indexes. So hence we have said ascending is equal to true. What it actually means is that the index that has the smallest value will be on the top in the resultant data frame, which we already know that Alice has the lowest, Bob has the second lowest, and then Charlie, and then David. So the resultant data frame will be exactly the same. So if we want to see any change here, what we can do is that uh, we can we can set the ascending is equal to false. So based on the indexes, the resultant data frame will be sorted accordingly. So since David had the highest index values, that is why David has been set on the top, and then Charlie, and then Bob, and then Alice. Okay, we already did that, and now what if we set the axis is equal to 1? So let's see its effect. So basically, um, by setting axis is equal to 1, it will sort the columns accordingly. So it is not considering the row indexes, rather it is considering the column labels. So that will be the base of the sorting. So now as we know that age has the age is starting with the letter A, and name is starting with the letter N, and score is starting with the letter S. So if we said ascending is equal to true, it means that the one with uh, the alphabet A will be at the start, and then the name will be at the second, and score will be at the third. So basically this is now sorting in the alphabetical order, and we also know that the age has the capital letter A, and its respective ASCII code will be fetched, and we know that the ASCII code of capital letter A is less than n. Similarly, the ASCII code of letter n is also smaller than the letter S accordingly. Okay, so now choosing the assorting algorithm, since we all know that there are a variety of algorithms, and based on the algorithms, each of them have the running time as well. So since this is a dummy data, so we may not be able to see the effect of the sorting algorithm if we select an appropriate. But if we have data that is very huge, or talking about the big data, or the data containing thousands of rows and thousands of columns, then sorting may take some considerable amount of time. So that is why selecting the appropriate algorithm will be definitely a key point. So a highly efficient divide and conquer sorting algorithm is select pivot, element, and partitions. We all know that how quicksort actually works. So everything is the same, except what we have done is that we want to sort over a data frame based on the age, and we also said that I want to select the quicksort algorithm by setting kind is equal to quicksort under the single columns. So first I will be displaying the original data frame, and then I will be displaying the sorted data frame. So we also know that sorting has been done based on the age. The one that has the smallest age has been on the top. We also want to ignore index is equal to false. Ignore index is equal to true, actually, not false. So the indexes will be resetting the resultant data frame as well. Moreover, in this time, the sorting algorithm used was the quick sort as well. Now, for setting the sorting algorithm as merge sort, what we can do is that we have to set kind is equal to merge sort, and then it will be set at the merge sort as well. And if we want to use the sorting algorithm as the heap sort, then what we have to do is that we have to set the kind is equal to heap sort, and the resultant data frame will sort based on the heap sort algorithm as well. Okay, now, how to apply a custom sorting logic. Using the key parameter, this is useful when we need to sort string in a specific way, such as ignoring case sensitivity. Just because we want to experiment the ignore sensitivity, so I have set the first letter of Bob as small b, and then Daniel as the small d, and the rest of the data set is the same. So what we can do is that we can use parameter key is equal to lambda, and then colon, and then colon dot string dot lower as well. So it will do it to sort an alphabet order, ignoring that case sensitivity ASCII values. So now, since small b may have a smaller ASCII value than a capital A, but since we have ignored the case sensitivity here, so capital A is still on the top, and and small b is still on the second spot after sorting the data based on the name column. So it's basically ignoring the case sensitivity here, and capital A, or in short anything starting with A, will be on the top, and anything starting will be on the second spot, and D and E as well. So this is it from today's lecture. I hope you have learned, and if you have any questions, then please state it in the comment section.